This is Greenfoot Chapter 3, Part A. There'll be a Part B in the next video. And in this video, we're going to improve our little crab from last time, make it a little more interesting. And so, yeah, I encourage you to follow along and code along if you can. There'll be points in this video in which I ask you to pause and try coding for yourself, and then I'll continue from there. So to start with, we're going to, well, let's just start with what we had last time. Our crab, as we designed it last time, I changed the code a little bit since where we left it last, but effectively does the same thing. Every time our crab moves when act is called, but if it's at an edge, which is a method that we inherited from our actor class, very useful for knowing if we're at the edge, we told it to turn a little bit so that it behaved a little more naturally instead of getting stuck. And then of course it moves every time. So our crab, it does move, but it doesn't do anything particularly interesting. To make it a little more natural, we'd like to add some random behavior to our crab. So to do that, we're going to take a look at the Greenfoot API again. If you remember, we can look at the documentation or the API for Greenfoot by going to the help and going to Greenfoot class documentation. And this time, we're going to look at the Greenfoot class. Last time we looked at actor, and we'll probably look again there soon, but we'll look at Greenfoot for now. So class Greenfoot is available to us, and there are lots of methods here that are designed to be useful in the Greenfoot environment at large. So if you scroll through, you see all sorts of things, and if you look, you notice that there's a method here called getRandomNumber. That looks like it might be useful for generating some random behavior. The parameters are, it just has one, an integer called limit. It looks like if we give it a limit, it will return a random number between 0 and limit. Note that it includes 0, but it doesn't include the number limit. So if we put in, say, 90, it will go from 0 to 89, but not 90. Somewhere, one of those random numbers. Quick note, it's not truly random. Programming languages have a really tough time generating real random numbers. Computers in general do, but it's some function that's pretty close to a random distribution. So for our purposes, it's good enough for random. Over here, as we noticed by the description, it returns a random number, and that happens to be an int. That's our return value. And you might have noticed this word here called static in front. Yeah, I'll get to that in just a minute. It's a bit of an advanced topic, but I'll bring that up in a second. And so to use this method, this belongs to the Greenfoot class. Now, our crab class is an actor, so it is also inherits all of the actor methods, but it's not an object, or it's not a Greenfoot class. That's a different class. So to use it, we will have to use what's called dot notation. So dot notation is very simple. Here, I'll write this down below. Dot notation requires that we write the name of the class or the object, and then dot, and then the method. So Greenfoot, since that's the name of the class that this method belongs to, and then dot get random number, and then we can put some number. So let's put in 100 perhaps. And now you might have noticed, well, why didn't we have to do that for our other methods, turn and move? Well, that's because turn and move, they're inherited. They belong to crab. Same goes for act. If we were to call act, we wouldn't have to use this dot because crab knows where to find them. They're part of his code. But since this isn't part of the crab class or the actor class, we have to use the dot notation to say, hey, we need this method and it's in a different class. Yeah. I said that I would explain the static part. So there's a slight difference between this method and some of the other methods we had before. Static methods are class methods as opposed to object methods. So to make that clear, methods can belong to either the class itself or objects of that class. It's a very slight distinction, but in this case, act, turn, and move are all object methods. They belong to objects of the type crab or actor. Get random number is different. It belongs to the class Greenfoot, and not any particular object of Greenfoot. I'm not even sure there is a particular, if Greenfoot ever gets made into an object at all, but they're available to the class. So yeah, the static word simply means that it is a class method, not an object method. You haven't seen an example of us needing dot notation for object methods yet, but we'll get to them in a later chapter. Okay, that was a lot of technical stuff, and we haven't even really written any new code, so let's get to that. So we would like to be able to make the crab do something random. I imagine that it would be nice if we can make him turn a little bit at a random point. So we'd maybe like some condition of randomness. So if something that happens a random portion of the time, then we will make him turn. So this is, again, all error-laden code, but we're going to fix it. So this if statement will only happen, the turn will only happen if this here is in here is true. And we'd like something that's only true, maybe say 10% of the time. So maybe we can use this random number here. So we'll take that command and put it in here somehow. Now, this has to come out to be a yes or no, a true or false, and right now it comes out to end as a number. But we can do a comparison with this number, so, and that can generate a yes or no. So if we use, say, the greater than or less than symbol, let's use less than symbol, and say if this random number between 0 and 100 is less than 10, that happens roughly 10% of the time. Then, with 10% chance, this will be true. And that means the if statement will run. The things inside the if statement will in fact happen. So, yeah, let's give this a try and see what happens. We compile, no errors, great, and put our crab out. And with our crab, every now and then, he turns a little. Not with any particular regularity, but roughly 10% of the time. Okay, that's pretty cool. Not bad. Maybe there's another way you can think of to get 10% other than doing getting a random number from 0 to 99 and seeing if it's less than 10. If you can think of another one, now is a good time to try it. I'll show you another one in just a second. So go ahead and pause and try and think of another way. Okay, so maybe you paused and thought of another way. I came up with this way. Instead of doing a number from 0 to 100, I did a number from 0 to 9. So I put in 10 as the limit instead of 0 to 9. And I used a different comparison operator here. I used the equals equals, which is necessary for testing equality. And I'm seeing if this random number from 0 to 9 is 0. And if it's randomly distributed, that means that it will happen roughly 10% of the time. So this is equivalent to the above. But I'll change it back to the first one for now. Okay, so it turns 10% of the time, and it turns 5 degrees to one side. It would be nice if this number here was also a random number. So, well, we know how to get a random number. So we can change its turning to some random amount. If we put in, instead of 5, get Greenfoot.getRandomNumber, and we can specify, maybe we'd like him to turn anywhere up to 45 degrees. And now if we try this, compile this, put a new crab in, and hit run. Oops, I made a mistake. So this is another type of error. This is not a syntax error or something that caused the code to not compile or run, but it doesn't run the way I meant it to. Notice that this here, instead of saying get random number, 100. If it's less than 10, then it makes this if statement run, then turn. I said greater than 10, which happens not 10% of the time, but 90% of the time, which is not the behavior we're going for. That's not particularly natural. So instead, change that back to less than instead of greater than, and we resolved our error. So now let's try that again. And now the crab, with 10% probability, will turn a random amount. So he doesn't always just turn a little bit. He turns up to 45 degrees. This is cool. The only issue right now is that he only turns in one direction. He only turns to the right or clockwise. So here's another point in which I'm going to pause, or encourage you to pause, and see if you can think of a way to make it turn not only a random amount to the right, but also possibly an equally random amount to the left. So go ahead and pause and give that a try. Okay, so hopefully you've given an attempt. I'm actually show you two different ways to make him turn left or right randomly. Here's my first way. So I decided to use the random numbers to determine whether or not he's going to turn left or right. If he's going to turn left, well, it's sort of like flipping a coin. So I did an if statement, and did Greenfoot get random number 50, or sorry, that should be 100, making mistakes. And if it's less than 50, which happens 50% of the time, then we should do what we did before, which is turn a random number up to 45 degrees to the right. If this is not true, then I have an else statement so that only if this isn't true, if we get a number from 50 to 99, then instead we'll turn 0 minus a random number from 0 to 44. So in other words, from 0 to negative 44. And so notice that we have this nested if statements. You can do this. You have if 10% chance at all that it turns, and within that, a 50% chance that it turns to the right, and a 50% chance that it turns to the left. So let's give this a try and see what happens. Now if we hit run, sometimes he turns to the right and sometimes he turns to the left. So we do in fact have random behavior as we would like. However, there's a more clever way to do this, and you may have already discovered it, but if you did this way as well, and you haven't thought of the other way to do it, go ahead and pause now and try and figure out another way, and I'll show you the other way in just a second. Okay, so here's the other way. Instead of using another if statement to kind of flip a coin and decide if I'll turn left or right, instead I did this. I chose a random number from 0 to 90, but then took 45 and subtracted that number from it. So that means we could get a number anywhere from negative 45 to 45, or off by 1 perhaps. In either of those, it might be negative 45 to 44. Regardless, it's pretty close to exactly half chance to the left and half chance to the right. So if we run this, we see that indeed it works just as well as the other one, and it uses a little less code. It might be worth explaining what it's doing. So really quick, a quick aside, you can write comments in Java. One of the ways is to use this /* and then write your comments and then end it with a */. Another way is to just put 2 slashes. This is a line comment, and this allows me to make it, anything I write after the 2 slashes will not be read as code. And so I can just describe turn with either left or right up to 45 degrees, just so that it's understood. Okay, so now we've got random behavior going in either direction. This is great. It makes for a little more of a realistic, interesting crab. We'd like to do one more thing in this video, is that we'd like to add something for the crabs to do. Namely, we're going to add some food, some worms for the crabs to eat. So a worm, if we're going to add a worm to this environment, we're going to need another class for worm. And that class will be a type of actor. So we're going to right-click actor, and you see new subclass. You can click that, and we'll get this nice little pop-up here. Let's give our new class name, let's call it worm, with a capital W. All classes start with a capital letter. And we can pick, in Greenfoot, an image to go with that class. So let's pick worm, and we'll go from there. So now we've got a cute little worm class. Note that it too is a type of actor, but it's not a crab. So they're both actors, so they share the same inherited code. But if we were to open the editor for worm, we see that he in fact does not have any code in act. So just for fun, put our crab out, put a few worms out. Oh, isn't he cute? And if we hit run, you notice that the crab runs around and he runs into the worms, but it doesn't do much right now. Well, that makes sense because we haven't to give any code added to worm or crab to determine what to do. We're actually going to focus still on the crab code. The worms for now, we'll just have them sit there. That's okay. We'd like the crab, if it runs into a worm, to eat the worm or make the worm disappear. So to do that, we might need some new code to be able to tell if, in fact, he's touching the worm. Obviously, crab doesn't have anything yet, but he inherits a lot of stuff from actor, so we want to check out the documentation. Remember that the open documentation link, unfortunately, doesn't work for actor, but we can go back to our Greenfoot class documentation, which I already had open, and we can check out the actor documentation again. In the API, we might find another method that will help us out. So if I scroll along, I find a class, or a method, sorry, called isTouching. It says checks whether this actor is touching any other objects of a given class. Oh, that sounds useful. There's also removeTouching. Removes one object of the given class that the actor is currently touching, if any exist. So both of these sound really helpful. It looks like isTouching gives us a Boolean. It'll tell us yes or no, true or false. And it takes, okay, this is interesting, a Java lang.class type. This is the type of the parameter. What this actually means is that we have to give it the name of one of our classes. This is another advanced aside, and so feel free to skip over this, but it's worth pointing out that this here is another use of dot notation, only this time, instead of it being a class and then on the other side of the dot a method, we have here what's called a package on the left, and on the right is the class. So classes have methods, and packages are comprised of multiple classes. So in this case, the java.lang package, which is available to all Java programs in Java, has a series of classes, and one of them is very confusingly called class, which is simply, well, yeah, we won't get into that, but just worth pointing out that this is the case. This is the package. Packages are in lowercase, java.lang, and then afterwards .class, which class is the is uppercase because all classes start with an uppercase letter. Okay, so let's use isTouching or removeTouching in our code. So we're going to say, again, this is something we would want to do only when it's touching. So this calls for an if statement. If isTouching. Now I have to remember this method is not an actor. So I can't just write isTouching because crab did not inherit this method. So we'll have to use our dot notation, say Greenfoot, because it's in the Greenfoot class. Or sorry, I take that all back. This is an actor. I forgot this is an actor one, so we don't need the dot notation. This is great, so we can just leave it as is. isTouching, and we need to give it the name of a class. So we're going to say worm.class. So if it's touching an object that has the class worm, then what will we do? We'd like to remove that one. So the removeTouching method looks like it will be helpful. Remove touching, and we also give it a worm.class. And this is more of a command sort of method. It doesn't have a return type, it's void, but it does something that we want it to do. Don't forget our semicolon, and let's give this a try. So we'll compile this, and got to put our crab back out here. Oops, well, just for fun, let's put out more than one crab. And let's put a few worms. Oh, if you hold down Shift and you click, just discovered this, that's really helpful. So, no, I don't want sticky keys. So, let's run this, and now, when the crabs run into the worm, it tells that it's touching it, and it causes it to disappear. It removes it. So, that last worm is very lucky. He's still alive. Great. So now we have a much more interesting scenario. We've got some crabs moving around randomly eating worms. I'm going to just add one more thing, talk about one more thing, and that's the idea of writing other methods. We've been writing this method act, but we can in fact write other methods beyond act. And the reason we might want to do so is to make our code easier to read. Right now there's a lot going on in act, and it kind of all meshes together. There's a lot of different things going on. So let's write a method called, we're going to write public. We'll explain what that means later. But the return type, void, and let's call it, let's call it look for worm. Look for worm. So all methods start with lowercase. That's the convention. It's for lowercase letters. So I'm going to move my picture up here so you can see. And look for worm. And put a couple parentheses because it, and then some curly braces. And the color blocks are helpful to tell me that yes, this is done correctly. All the code that goes in this block will be look for worms. And we're just going to take the code from act that did the part where it looked for a worm and removed it. So let's take that out and put that inside of look for worm. So now I've got a whole nother method that says look for worm, where it can handle the worm thing. And if I were to just leave it like that and run it, let me put a crab out there and put a worm right under it or on it. Now if we were to right click crab, we can see that we have another method, look for worm. And if we do that, it'll do what it did before. It checked if there was a worm there and it removed it. Now we want this to happen in the act, but now we can do this. We can call the look for worm method inside of act. It does exactly the same thing it did before, but it makes our code cleaner and breaks things out into their specific functions. So now it's a little clearer that acting involves all this, and then it looks for a worm and does this. So I'm going to challenge you to write a couple more methods and to clean this up a bit. Think about what you might call them, what parts of this this code in act could be broken off into their own little things so that it's more understandable. Go ahead and pause the video and try that, and you can check in with how I did it in just a second when you come back. Okay? Okay, we're back. So you can see that I've written two more methods. I wrote turn at edge, and I took the part of the code where we would check if we were at the edge and turn a little bit. And I also wrote random turn, which I took all the parts about 10% of the time turning a random amount to the left or the right. And now you can see that by replacing, moving that code and then replacing it with a method call in act, it's very clean and very clear what we do. When we call act, we're turning at the edge, we're moving a little bit, we're making a random turn sometimes, and then we check if there's a worm and eat it if it's there. If we no sticky keys, please. We put a few worms out there with some crabs. We can see that in fact it still does exactly what it did before, but it's a little easier to understand. Okay, so now we've got a great little scenario, predator-prey sort of thing going on. So what I'm going to leave you with for this final challenge, last pause and program section, and I'll show you what happened, what it looks like if you get it right afterwards, is for you to do this. The crabs are a little too strong right now. They eat all the worms without any trouble. So I want you to create another object. I want you to make a lobster class that's also an actor. And the lobster acts a lot like the crabs, except for he eats crabs. So so a lot of the code that you'll write for lobster will look a lot like crab. Make it behave similarly, where it doesn't get stuck at edges, it makes random turns, and of course, importantly, it eats crabs. So go ahead and write that, and we'll see how that's supposed to look in just a second. Okay, so I've made my lobster class, and I've added some lobsters and crabs and worms to this environment. So if it does what it's supposed to do, the lobsters run around. If they touch a crab, they eat the crab. So this time now the crabs aren't as free to eat all the worms. A little bit more interesting of a simulation. I made the lobsters move less often but turn more erratically, just for a little fun and difference. Yeah, so if you successfully make something happen, it will look a little bit like this when you run it. Okay, that's enough for today, and I'll see you next time.